students, welcome to my classroom, and in this video I am going to discuss some exercises from the chapter matrices. Okay, I have discussed some theory part of the chapter matrices, and in this video we have to solve some exercises problem. Okay, so see the first problem. The first problem is find the matrix X where X equals to A plus B minus C. Second one, 2x equals to A minus C, and given that A, B, C. That means here three matrices are given, A, B and C, and you have to calculate the matrix X. Okay, this is the first problem, this is the second problem. Is it clear? So see here, all the matrices A, B, C are of the same order. That means first one is a column matrix, second one is a column matrix, and third one also a column matrix. Okay, and we have to actually X equals to first one, A plus B minus C is given. Okay, and you have to solve for X. So to solve the first one, directly we can put the value of A, B and C. Here A, B, C are matrices. Okay, so I am solving the first one. Solution. First one, X equals to A plus B minus C. So put the value of the matrix A means 1, 1, 2, B means minus 2, minus 1, minus C means 1, minus 3. So now solve. I told you that matrix addition and matrix subtraction always possible when the matrices are of same order. Clearly each of the matrices are of same order, and matrix addition and matrix subtraction means you have to add or subtract the corresponding element. So first element and first element we have to add or subtract whatever is given here. So if we directly we can solve it. So then 1 plus of minus 2 minus 1, this complete the first element, and for the case of second element 2 plus of minus 1 minus of minus 3. Okay, so now simplify, equals to 1 minus 2 minus 1. That means it will become 1 minus 2 minus 1, and second element will be 2 minus 1 plus 3. Okay, this is nothing but minus 2, and this will be 4. So this completes the solution, the first one. So this is our X. Understood? Now second number problem. Second number problem we have to derive X, and given that 2x equals to A minus C. So 2x equals to A minus C. So second one, given that 2x equals to A minus C gives. Now put the value, since A and C are given, you know. So 2x equals to A minus C. Put A is 1, minus of C means 1 minus 3. So if you simplify these two, then 1 minus 1, that means 0, and 2 minus of minus 3, that means plus 3, so it is 5. So we get 2x equals to this. Therefore x will be, we have to divide by 2. So 1 by 2 into 0 by 0, 5. Okay, since division is not possible here, not possible means we can divide by 2 each and every entries of this matrix, but since 5 is not divisible by 2, that's why we keep it into this form, that 1 by 2 into 0, 5. Understood? So this completes the second solution. Okay, next problem. Find the matrix A satisfying the equation 2A minus a matrix is there equals to another matrix is there. So we will solve based on our previous concept. Okay, actually these are called matrix equation. So solution. So given that 2A minus 3 minus 2 4 5 equals to another matrix in right hand side, minus 5 8 minus 2 5. So we have to solve for A. So we keep this A into left hand side and consider all the terms in another side. Here terms mean a matrix. Okay, so this matrix already was there, minus 5 8 minus 2 5. This already is there. If we consider this matrix into that side, then it is negative in left hand side. So if we consider this matrix in right hand side, then it will be positive. So plus 3 minus 2 4 5. Okay, so if we add, implies that 2a equals to, if we add the corresponding entries, then minus 5 plus 3. We have to add these two matrices, and two matrix addition means what? Addition of corresponding entries or corresponding element also. So minus 5 plus 3, that means minus 2. 8 plus of minus 2, that means 6. Minus 2 plus 4, that means 2. And 5 plus 5 means 10. Okay, so to get a, implies that a equals to what? We have to divide by 2. So we will not write into this way. Okay, a equals to, suppose you don't write into this way, that minus 2 6 2 10 by 2. Don't write into this form. Actually this is we will not use this symbol. We will use into this form, that 1 by 2. Okay, 1 by 2 of these two we have considered this side, then it will be 1 by 2 of minus 2 6 2 10. Same thing actually. Half means we have to multiply by half each and every entries. Okay, so ultimately we will get multiply by half and division by divided by 2, same concept. Understood? Suppose you are multiplying, I am giving an example. Suppose 6 divided by 2, this concept, and 6 multiplied by 1 by 2. These two are same thing. Why? 6 divided by 2 means 6 by 2, and it is also 6 by 2. If you multiply numerator, then 6 by 2. So these two are same concept. Okay. So divide this matrix by 2 and half into this matrix. These two are same concept. So answer will come. So if you multiply by half, then it is minus 1. This is 3. This is 1. This is 5. So this is our A. This complete this solution. Hope you understand. Actually, this is a very easy problem. Okay. Next problem. Next 6 number problem. See, given that let A equals to a matrix is given, B another matrix, C matrix given. Just you have to find A square minus A plus B. So you have to calculate this. Okay. So very easy problem. So first we need A square. Okay. I am solving it. First we need A square. A square means what? A square means we can write A into A. Okay, so we need the concept of matrix multiplication. So A into A means 4 minus 2, 6 minus 3 into 4 minus 2, 6 minus 3. We have repeated time considered A into A. So if you multiply this, then equals to, I told you that in the case of multiplication, we have to consider a row. I am first considering the first row. Okay, first row. After that, fixed it and consider inner product with each of the columns. So first row, if we fix the first row, then inner product with the column 1. So inner product with the column 1 will be 4 4 is 16. 4 4 is 16 plus here 6 2 is minus 12. Minus 12. So this is the inner product with first row and first column. Row fixed. Okay. Now with second column. So with second column will be 4 into minus 2. That means minus 8 plus. If you multiply these two, then 3 to just 6 and it will be plus 6, obviously 6. Okay, next. Next, first row done. Now consider second row and inner product with first column. So second row and first column means 6 4 is 24 plus 3 6 are 18, minus 18 obviously. Okay, now with second column, then 6 2 are minus 12 plus 3 3 are 9. Okay, equals to, we get 16 minus 12 means 4. This is minus 8 plus 6. Minus 8 plus 6 means minus 2. 24 minus 18, it will be minus 18, so 6. And 12 plus 9 means minus 3. So this is our A square. Okay. Now we need also BC. We can calculate BC, but directly we will solve. Okay. Or you can calculate now. And BC equals to, BC means multiplication of B and C. B is 0, 2, 1, minus 1, and C means minus 2, 0, 1, minus 3. So equals to, I will solve here directly. Okay, this fix the, consider the first row and fix it, and inner product with first column. So it will be 0 plus 2, that means 2. Now with second column, then 0 and 3 2s are minus 6. 0 minus 6 means minus 6 itself. This complete with the first row. Now consider second row. And with first column. With first column means it will be minus 2 plus of minus 1. That means minus 2 minus 1. That means minus 3. Now this and this. So 0 plus, if we product this, then plus 3. So 0 plus 3 means 3. So this is our BC. Understood? So now we have A square, BC and minus A. So just put the values, then you will get the answer. I am solving here. Therefore, A square minus A plus BC equals to, put the value. A square means the matrix 4 minus 2, 6 minus 3, minus A means matrix 4, this is A, plus BC means this 2 minus 6 minus 3 minus 3. So if we apply the operation among corresponding entries, then 4, first element 4 minus 4, 0, 0 plus 2, then it is 2 itself. Next second element minus 2, minus plus 2, minus 2 plus 2, 0, plus of minus 6, that means minus 6. You can solve partly. Okay, 6 minus 6, 0, 0 minus 3, that means minus 3. Okay, minus 3 plus 3. Actually these two matrices are same matrix. Okay, you can cancel out also. These two matrices will come a 0 matrix. This matrix and this matrix same, so we can cancel out these two matrices since plus minus is there. So ultimately answer will be this matrix. Okay, directly we can solve minus 3. So this is the solution. Understood? Next. Okay, next problem. Work out if possible. This is the first matrix, dot second another matrix. That is matrix multiplication. You have to simplify or find out the matrix multiplication value if possible. Okay, and this is the second one. So first you have to check that matrix multiplication is possible among these two matrices or not. Okay, so how to check? Solution of first one, A. See, here 2, 1, 3, 1, 2, 6. Okay, dot 1, 4, 7, 2, 1, 3. This equals to what? Matrix multiplication means always you have to consider a row and fix that. After that, okay, I am considering the first row. First row means this row. This is the first row, and fix it. and we have to consider inner product with first column, after that second column. So first I am considering this column. So what will be the inner product of this among these two? Among these two, the inner product will be 2 first element into first element. So 2 into 2, 2 into 1, 2 plus 1 into 4, that means 4 plus 3 into 7, 21. So this complete with first column. Now we have to do with second column, this. So if we consider this with second column, then 2 into 2, 4 plus 1 into 1, 1 plus third into third, that means 3 into 3, 9. So this complete with first row. Now consider the second row and do the same. Then if we consider this second row, then now multiply with first column, that means inner product with first column. Then 1 into 1, 1 plus 2 into 4, that means 8 plus 6 into 7, 42. So this complete with first column. Now with second column, then if we consider the second column, then 2 into 2, 2 into 1, 2, and 6 into 3, 18. So now simplify it. Then 4 to 6, 6 plus 21, 27. This is 50, it is 51, and it will be 14, and it is 22. So matrix multiplication is possible here, but before solve this problem, you have to declare that matrix multiplication is possible here. So what was the condition? That suppose A is a matrix of order n cross n, and B is another matrix order n cross p. Then matrix multiplication with A and B, that means A dot B possible. This was from theory part. Possible if these two n, that means I have written into this way, n cross n is the order of first matrix, n cross p is the order of second matrix. If these two are equal, so these two are equal means this number says the number of column of first matrix, and this says the number of row of second matrix. So what was the condition? That matrix multiplication possible if this was matrix multiplication possible if number of column of first matrix equals to number of row of second matrix. If it holds, then matrix multiplication possible, otherwise not possible. Okay, so before solve this part, you have to check, since according to the question work out if possible. So first you have to declare that matrix multiplication is possible here. Okay, so before this you have to write this line, that what is the order of this matrix. If we take, then order of this matrix is number of row cross number of column. So number of row is 2 and number of column is 1, 2, 3, 2 cross 3. And what is the order of this matrix? Number of row is 3 and number of column is 1, 2. So since these two number equal, so matrix multiplication possible, and the resulting matrix, that means after multiplying you will get a matrix of order 2 extremities, that means 2 cross 2. See, here we have got a matrix of order 2 cross 2. So what you have to write here? So you have to write that since, before solving this part, okay, you have to write this. Actually I have solved, but before solve you have to write this line. You have to do this one, and you have to write that since number of row, number of, this says number of column, this is number of column of first matrix, number of column of first matrix is equals to, this says, actually this gives number of row of second matrix. So equals to number of row of second. Okay, since this is equal, therefore matrix multiplication is possible. Matrix multiplication is possible. After that you have to do this part. Understood? Okay, just you have to you can memorize this one. It will be better. That number of column of first matrix equals to number of row of second matrix. It should be equal if matrix multiplication is possible. If this is not equal, then matrix multiplication is not possible. Clear? So this complete the first solution. Now problem number C. Next, C. Check. Here, if you try to multiply these two matrices, then you have to consider inner product. So row with column. See, here in row there is 1, 2, 3, 4 elements, but here 1, 2. So inner product is not possible. That means you can realize to multiply these two matrices, that matrix multiplication is not possible. So now you have to write the reason. So what was the condition for two matrices multiplicable or not? Number of column of first matrix should be equals to number of row of second matrix. If it is true, then matrix multiplication possible. Otherwise, matrix multiplication is not possible. So here check. Here matrix multiplication not possible. You have realized it. Just you have to write the reason. So what will be? Right? Since number of column of first matrix is what? Number of column? You have to count column along vertical way. 1, 2, 3, 4 is 4. Okay, not equals to number of row of second matrix. And number, right? The number of row is 1, 2 is 2. Okay, therefore matrix multiplication is not possible. Matrix multiplication is not possible. Multiplication is not possible. Since matrix multiplication not possible here, so what will you do? So since matrix multiplication not possible, so we have not to do. Understood? Okay. Next problem. Okay, next. Find x and y if a matrix equation is given. So solve. Here I am solving the 11 number. 11 number is given that 1 0 0 minus 1 3 4 equals to xy. Very good. So in right hand side there are product of two matrices. So just product these two matrices, then we will get a single matrix. After that we will compare with the right hand side. So if we consider the matrix multiplication, then it will be, first consider the row and column. So 3 into 1, 0 into 4. 3 into 1 means 3 plus 0 into 4 means 0. So it is 3. So first row, consider the first row and fix it, and inner product with first column done. No more column is there, so we have not to do this. So now consider the second row. If we consider the second row, then this is second row and inner product with this column. So 0 into 3 0 and minus 1 4. That means minus 4. So this is the matrix equals to x comma y, x y. So what is the value of x and what is the value of y? Now compare these two. So by comparing, x equals to, obviously since these two matrices are equal, so x means this and y means this. X equals to 3 and y equals to -4. This complete the solution. Understood? Next, 25 number problem. For 25 number problem, given that 5, 6, 7, 8 equals to A, B, C, D and multiplied with 1, 0, 0, 1. Okay, implies that keep it unchanged. 5, 7, 6, 8 equals to, if we multiply these two, then row and column, then row, if we multiply row and column, then A into 1 means A plus B into 0 means 0. So only A. So now first row, first column done. So first row with second column. Always you have to consider a row and fix that row and complete the inner product with each and every column of second matrix. Okay. So we have considered first row and fixed it. After that we have done the inner product with first column. Now we have to do the inner product with second column. So inner product of second column will be A into 0 means 0 plus B into 1 means B. Okay. Similarly for this you will get back, actually since this is the identity matrix, so you will get back this matrix itself. Okay. Now compare. So by comparing, what? A equals to 5, B will be 6, C will be 7 and D equals to 8. Actually this is the property, okay, that if we multiply any matrix with the square matrix, then we will get back that matrix. Okay, see here, this is a matrix and this is identity matrix. So if you multiply these two, then we will get back this matrix. Okay. This complete the solution. Next, find x, y if a matrix equation is given. Okay, so we will solve by the concept of previous problem. Okay, so I am considering the given. Here given that 2 into x 7 9 y minus 5. Okay, plus 6 minus 7 4 5 equals to, given that 10 22 7 15. Okay, now convert the left hand side into a single matrix. So if we convert this into single matrix, then first multiply by 2, then it will be 2x 7 to the 14. Since this is scalar multiplication, so you have to multiply 2 with each of the entries of first matrix. So 2x 14, 9 to the 18, and this will be 2y minus 10. Understood? Plus, you can do directly also. 4 5. Since you are the students of class 10, that's why I am solving without jump any step. It implies that. So if we add these two, then the first element will be 2x plus 6. Second, then 14 minus 7, that means 7 itself. 18 plus 4, that means 22. And for this one, 2y minus 10 plus 5, that means 2y minus 5 itself. Equals to 10, 7, 22, 15. Now compare the corresponding entries. This actually first position equal, second already equal, third already equal, so fourth equal. Okay, so by comparing, what? 2x plus 6 equals to 10. Okay, implies that 2x equals to, if we consider this 6 into another side, then it will be 4. Therefore, x equals to 2 divided by 2. Okay, by dividing by 2. So this is the value of x, and if we compare this position, then we will get 2y minus 5 equals to 15, and 2y minus 5 equals to 15 implies that 2y equals to 20. Therefore, y equals to 10. So this completes the solution. Hope you understand. Okay, next. So that if m equals to a matrix given and m square minus 6m plus 9i, okay, 9i, this is not 9 to 1, 9i equals to O. This is not 0, this is O. O means a null matrix. What was the definition of null matrix? If all the entries of a matrix is 0, then that matrix is called zero matrix or null matrix. Okay, and zero matrix or null matrix is denoted by O. If all the entries 0, 0, 0, 0, all the entries should be 0. Okay, so see the first, see the solution. Okay, here m is given, and given that this equation must be satisfied, and we have to prove it. Okay, so to prove it we need m square. So first calculate m square. M square equals to m into m. So put the value of m, then 4 minus 1, 1, 2. Again write 4, 1, minus 1, 2. If you multiply these two, then it will be 4, 4 just 16 minus 1, that means 15. 4 1s are 4 plus 2 1s are 2. So 4 plus 2, 6. Now second row and first column. Second row and first column means minus 4, minus 2, that means minus 6. And second row, second column. So 1 into minus 1, 1 into minus 1 plus 4, that means 3. So this is m square. So left hand side, consider the left hand side. Okay, so left hand side is m square minus 6m plus 9i. Now put the values. M square means we have 15, 6, minus 6, 3, minus 6m. That means we have to multiply. Okay, I am writing one line. Then 4, 1, minus 1, 2. This is m plus 9. I means an identity matrix of order 2 cross 2. I told you about identity matrix. Identity matrix means 1, 0, 0, 1. This is the identity matrix of order 2 equals to. Now, this is 15, 6, minus 6, 3. Now multiply with 6, then it will be 4. Since 6 is scalar multiplication, so we have to multiply with each and every entries. So it will be 24, 6, minus 6, 12 plus, for this one again same thing, 9, 0, 0, 9. Very good. Now equals to 15 minus 24, that means 9, minus 9. 15 minus 24 minus 9 plus 9. Just we have to add or subtract whatever is there in the among the corresponding entries. Okay, so 15, since minus is there, so 15 minus 24, that is minus 9, minus 9 plus 9, that means 0. 6 minus 6, 0, 0 plus 0 means 0. Next, minus 6 plus 6, that means 0 plus 0, that means 0. And 3 minus 12, that is minus 9, minus 9 plus 9, 0. So we get O matrix equals to matrix O. Proof. We get a null matrix, so this completes the proof. Understood? Okay. Next. Okay, next. Let M cross a matrix equals to 13, 4, where M is a matrix. First question is state the order of M. That means you have to state the order of M, matrix M, and find M. Solution C. So before solve this problem, I am discussing again just to remind you that if A is a matrix which is of order n cross n and B is another matrix of order n cross P, then since these two entries, these two number equal, so matrix multiplication is possible, and if the resulting matrix is C, then C will be of order these extremities, that means M cross P. Okay, so here if we use this concept, then here given that, see, M cross 2, 5, 3 minus 2 equals to 13, 4. So here M is the order of M is not given, and order of this is 2 cross 2. Okay, and the resulting matrix is of order, how many rows are there? 1 row and 2 column. Just compare with this. Here we get 1, 2 resulting matrix. Second matrix is of order 2 cross 2. Then what will be this? This again 2, since n is 2 here, so it will be 2. And ultimately we get the extremities. Here P means 2, N means 2. Okay, M means 1 and P means 2. So here M must be 1. See, here M is 1. So M is here order of M will be 1 cross 2. Understood? Understood or not? Okay. So you have to write this part, okay? This theory part. Since we know that A is a matrix which is of M cross N, B is a matrix which is of order N cross P. After multiplying these two matrices, if we get a matrix C, then C will be of order M cross P. Okay, so by comparing here M cross P means what? This, just write the order here, it will be better. If we write the order, then order of this is 2 cross 2, this is 2 cross 2, and order of this is, number of row is 1, this is column is 2. That means the resulting matrix is of order 1 cross 2, and this is 2 cross 2. That means second matrix. So what about the first matrix? See, here easily we get M equals to 1, P equals to 2. So P equals to 2, N equals to 2. So this N again 2 and M is 1. You can do this. Okay, it will be better, I think. By comparing, we get order of M is 1 cross 2. So this complete the first solution. Okay, state the order, this part completed. Now find M. So we get an idea that M should be of order 1 cross 2. Okay, so to solve second one, we are considering let M equals to a matrix which have 1 row and 2 column. That means X, Y. Just we assume it that M will be this. After that we have to solve X and Y. Then we will get the matrix M. Okay, see, this is the matrix of order 1 cross 2. So let M equals to this. Now put here. This is the second part, okay? If you put here, then implies that according to this assumption, X, Y cross 2, 5, 3 minus 2 equals to 13, 4. Now multiply these two, then it will be only one row is there, so this row with this column in our product, then it will be 2x plus 3y, and no more this row with this column now, so it is 5x minus 2y, this equals to 34. So by comparing we get what? 2x plus 3y is equals to 13 and 5x minus 2y equals to 4. So this is a linear equation of two variables. Okay, so you can solve this problem or this part by using any one process of substitution method, elimination method, cross multiplication method. You can use any one. Okay, so we are mostly habituated with elimination method, so we are eliminating. So to eliminate it, we have to multiply the first equation. This is 1, this is second equation. Multiply first equation by 5 and second one by 2. Okay, I am solving on this side. So if you multiply first equation by 2, then it will become 10x plus 15y equals to 65, and for 2, 10x minus 4y equals to 8. Now subtract, then minus plus minus, so this term cancel out and this will be 19y equals to, if we subtract 8 from 65, then it will be 57, implies that y equals to 57 by 19 equals to 3. Okay, so we get y. Now put the value of y in any one equation, so put in 2, then you get x, so 5x minus 2 into y means 3 equals to 4, implies that 5x equals to 4 plus 6, therefore x equals to 2. So now we have x equals to 2 and y equals to 3. Okay, see here x equals to 2 and y equals to 3. Hence the matrix M equals to what? Therefore M equals to matrix was x comma y, so put the value, x means 2 and y means 3. So this completes the solution. Understood? Next, some important result. Some very important result. Okay. Okay, I am considering an extra example. If next problem, if a equals to 2351, then find a plus 80. So first you have to introduce with 80. What is 80? Actually 80 means 80 is called transpose of a matrix. First I am discussing about transpose of a matrix. Transpose of a matrix. Okay, transpose of a matrix means just you have to interchange the row and column. That means you have to make the row into column, then the resulting matrix is called transpose of a matrix. Okay, so I am considering an example. Then if suppose a equals to 2 3 5 1 2 0, then the transpose of this matrix is denoted by 80, and some books also denoted by a dashed also. Okay, so 80 or a dashed equals to, just you have to make each row into the column. So first row is 2 3 5, so since this is row, we will make it into column. So 2 3 5, see, it was row but I have written here into column, and second row into second column, then 1 2 0. So this is the definition of transpose. Okay, so I will solve the first problem. Hope you get the idea. Next, solution. Here given that A equals to 2 3 5 1, then what about 80? 80 will be, just consider the transpose. Then 2 3 is first row, so make it column, then 2 3, and 5 1 is second row, so say 5 1. Now A plus, see, find A plus 80 and A 80. So A plus 80 means what? 80 itself a matrix, so A matrix 2 3 5 1 plus, put the value of 80. 80 is 2 5 3 1, sorry, this is. Now add the corresponding entries as usual, matrix addition. So 4 8 5 3 8 1 1 2. So this complete the A plus 80, and to compute A 80, put the values 2 3 5 1. This is matrix A dot 80 means 2 3 5 1. Now consider the multiplication, then you will get the answer. So in the case of multiplication, it will be 4 plus 9, that is 13, 2 10 3, again 13 13 26. So this completes the first solution. Okay, next, see the second one. For the second problem, A is given 2 3 1 5 0 2. Then what will be A transpose? A transpose will be, just change the row into the column. So the first column will be 2 3 1 and 5 0 2 is the second column. Okay, so A minus 80. To compute A minus 80, see, find if possible is there. So first you have to check the possibility of this A and A transpose. So here A equals to 2 5 3 0 1 2 minus A transpose means 2 3 1 5 0 2. Actually here matrix subtraction is not possible. Why? Since the first matrix is of order what? Number of row is 2 and number of column is 3. So the order of first matrix is 2 cross 3, and the order of second matrix, number of row is 3 and number of column is 2. So I told you in my first video that matrix addition and subtraction possible only when the order of matrix should be the same. Okay, so here order of matrix is 2 cross 3, but here order of matrix is 3 cross 2. So matrix subtraction is not possible. So write that A minus 80 is not possible. Is not possible. So this complete the first solution. Understood? Similarly, A80, if you try to compute A80, then A80 also not possible. Oh no, sorry, A80 possible. Next, second part, A80. A80 equals to, put the matrices 5 0 2 and 80 means 2 3 1 5 0 2. Since they have number of elements along row 1 2 3 and along column 1 2 3, so since these two are same, so matrix multiplication possible. So now multiply these two matrix, then consider the first row and fix it, and inner product with first column. So if you consider the inner product with first column, then 2 2s are 4 plus 3 3s are 9 plus 1 1s are 1. Okay, so this done the first column. Now with second column, so if you consider the second column, then 2 into 5 10 plus 3 into 0, that means 0, plus 1 into 2 means 2. So this complete with first row and each column of the second matrix. Now consider the second row and consider the inner product with each and every column of second matrix. So second row and first column, so it will become 10 plus 0 plus 2, and with second column it will be 25 plus 0 plus 4. Okay, so now simplify, then you will get the answer. Actually 4 it will be 14 It is 12, this is 12, and this is 29. So this complete the solution. This is our A80. Understood? Next was to BA. Okay, we have to check it that AB equals to BA or not. So I told you in my first video that matrix multiplication is not commutative. That means in general, if you consider A and B, then AB and BA, these two matrices are not equal. Okay, so just to remind you, I am considering this example. So just simplify A and B. I am solving it short. So A dot B equals to 2, 3, 4, 5 dot 1, 3, 2, 0. So equals to row column. So 2 1s are 2, 6, 8, 3 2s are 6, 4, 10, 14, and 12. This is AB. Okay, and BA equals to 1, 3, 2, 0 dot 2, 3, 4, 5. So if multiply these two, so then it will be 2, 3 4 is 12, 12 plus 2, 14, 3 and 15, 15 plus 3 is 18, 4 and 6. See, here AB means this matrix and BA means this matrix. So AB and BA here not equal. Okay, so we can conclude that matrix multiplication is not commutative, and this is the example that matrix multiplication is not commutative. Okay, now some interesting problems that in matrix theory, A plus B whole square equals to A square plus 2AB plus B square. Is it true? This is the question. Is it true? The answer will be no. This is not true in matrix theory. Okay, why? Actually, A plus B into A plus B. The answer is no. Okay, answer is no. Since A plus B whole square, if A is a matrix and B is a matrix, then A plus B itself a matrix. It can be written as A plus B into A plus B. So if we apply the distributive property, then A into A means A square, A into B means plus AB plus BA plus B square. Okay, so A square, very good. In number system, AB and BA was same thing. Okay, that's why we can change this BA into AB in number system. If we consider a number, see, I am solving here in this side. In number theory, when A plus B whole square, if you expand it, then A plus B into A plus B equals to A square plus AB plus BA plus B square. Okay, equals to, in number theory, AB and BA was same things. That's why in the place of BA we can write AB plus B square. After that, this AB and this AB togetherly 2AB. Okay, so this is possible since here AB equals to BA in number theory, but in matrix theory, A dot B and B dot A, these two are not equal. Okay, so this is not true, that A square plus 2AB plus B square. Understood? So we have to write that since, now we have to write since, this is the main solution. Okay? Since, this is the rough part, AB not equals to BA in general in matrix theory. Therefore, A plus B whole square equals to A square plus 2AB plus B square is not true. Okay, understood? Similarly for minus also not true. Here if we consider minus, then minus, and these two are same thing, so this property is not true. Okay, next, in short, the answer is, since matrix multiplication is not commutative, that's why it is not true. And so many results also there, that A plus B into A minus B equals to A square minus B square. Is it true in matrix theory? Again, answer is no. Why? Since matrix multiplication is not commutative. Okay, why it is not true? If you expand it, then you will get the answer. If you expand, then you will get A square minus AB minus plus BA minus B square. So are you sure that AB and BA are same matrix? You will get the same matrix. If you will get the same matrix, after that you can cancel out. Since AB and BA not equal, so since AB not equals to BA, so the above is not true in matrix theory. Above is not true in matrix theory. Very important information is there. Matrix theory. Okay. This information is not true since matrix multiplication is not commutative. Okay. So this completes the chapter. I think rest all the problems you can solve by yourself, since I have solved in this video all the different type of problems. Okay. And rest all the problems are basically same type of problems are there. So this completes the chapter. In my next class I will start a new chapter.
Please subscribe my YouTube channel and press the bell icon so that you get the notification of all updates.